There is a place in the universe where physics breaks down, where light itself cannot escape, where time slows to a crawl and matter is crushed into an infinitely small point. We call this place a black hole, and it is the most extreme object the cosmos has ever created. A black hole begins as a star, but not just any star. A giant, burning thousands of times brighter than our sun. For millions of years it burns, held together by the perfect balance between the outward pressure of nuclear fusion and the inward pull of its own gravity. Then one day, the fuel runs out, and gravity wins. In a fraction of a second, the core collapses. The outer layers rebound in a catastrophic explosion, a supernova bright enough to outshine an entire galaxy for weeks. And at the center of that explosion, something extraordinary remains. The core has collapsed so completely that nothing can stop it. Gravity has become infinite. Space itself has been torn open. What remains is a singularity, a point of infinite density surrounded by a boundary called the event horizon. Cross that line, and you will never return. From the outside, looking into a black hole is like looking at the end of the universe. The event horizon appears perfectly black, because every photon of light that reaches it is swallowed, never to escape. But if you could hover safely above it and look down, you would see the reflection of the entire universe behind you, bent and distorted into a perfect ring of fire. Physicists call this the photon ring. It is, without question, one of the most beautiful things the cosmos can produce. But what happens if you cross that boundary? The answer depends on the size of the black hole. Fall into a stellar black hole one with a mass of just a few suns, and you would be spaghettified. The gravity at your feet would be so much stronger than at your head that your body would be stretched into a thin stream of particles, spiraling inward through an eternal darkness. But fall into a supermassive black hole, one weighing billions of suns, and the experience is almost peaceful. The tidal forces at the event horizon are gentle enough that you might not feel anything at all. You would simply fall, and fall, until the singularity pulls you apart at the subatomic level, adding your atoms to an infinite collection. The largest black holes are found at the centers of galaxies, where they can weigh billions of times more than our sun. 2. These supermassive black holes are thought to have formed through the merger of smaller black holes, and they play a crucial role in shaping the evolution of their host galaxies. 3. The study of black holes has led to a greater understanding of the fundamental laws of physics, and has challenged our understanding of space and time. At the center of our own Milky Way, 4 million light-years from where you sit right now, there is a black hole called Sagittarius, a star. It weighs 4 million times more than our sun. Every night, as you sleep, entire stars are orbiting this invisible monster at thousands of kilometers per second. We know it is there only because we can see those stars dancing around something we cannot see. In 2019, for the first time in human history, we photographed a black hole. The image showed the black hole at the center of galaxy M87, a beast 6.5 billion times more massive than our sun. What we saw was a ring of glowing gas swirling at nearly the speed of light, surrounding a perfect circle of darkness. We were looking at the shadow of infinity. And yet, as terrifying and extreme as black holes are, they may also be the universe's most creative force. Their gravity pulls matter together. Their energy triggers the formation of new stars. Planets coalesce, and on some of those planets, life finds a way. We exist because stars lived and died. We exist because black holes formed. The universe's most extreme places are also the reason we are here to wonder about them. The story of black holes is not a story of destruction alone. It is a story of what happens when the universe pushes matter to its absolute limit, and what is born from the aftermath. Fact 1. The formation of black holes is still not fully understood, and scientists continue to study these objects to learn more about their role in the universe. Fact 2. The detection of gravitational waves from merging black holes has opened a new window into the universe, allowing us to study these objects in ways that were previously impossible. The universe does not fear its darkest places, and neither should we. What will we discover next? Will we uncover the secrets of black holes, or will they remain a mystery forever? The universe is full of questions, and we are driven to find the answers. Imagine compressing the entire mass of our sun into a sphere the size of a city. A sphere you could walk across in an hour if you could survive a single step. What you have just imagined is a neutron star, the densest object in the known universe that we can actually observe. And what happens inside one defies everything our everyday experience tells us is possible. When a massive star dies in a supernova explosion, it does not always leave behind a black hole. Sometimes, if the conditions are exactly right, the core collapses into something stranger. The protons and electrons of every atom are crushed together under unimaginable pressure, until they merge, forming neutrons. The result is a ball of pure neutron matter, roughly 20 kilometers across, containing more mass than the Sun. A single teaspoon of neutron star material would weigh approximately 1 billion tons on Earth. Not a kilogram, not a ton, 1 billion tons. That is the mass of a mountain, compressed into a space smaller than your thumbnail. The surface of a neutron star is not rock or metal as we understand it. It is a crystalline lattice of atomic nuclei so compressed that the electrons have been stripped away entirely. The surface gravity is 200 billion times stronger than Earth's. If you dropped a marshmallow onto a neutron star from a height of 1 meter, it would strike the surface with the energy of a nuclear bomb. But the most astonishing neutron stars are the ones that spin. When a star collapses into a neutron star, it conserves its angular momentum, the same principle that makes a spinning ice skater speed up when they pull in their arms. A star that rotated once every few weeks suddenly, in the moment of collapse, begins spinning hundreds of times per second. These rapidly spinning neutron stars are called pulsars, and they are nature's most precise clocks. One, pulsars emit beams of electromagnetic radiation from their magnetic poles. 2, as they spin, those beams sweep across the universe like a cosmic lighthouse. 3, every rotation is so precise that astronomers can use pulsars to measure time more accurately than any atomic clock on Earth. The fastest pulsar ever discovered, known as PSR J1748-2446 AD, spins 716 times every second. In the time it takes you to blink, it has rotated more than 50 times. Its equator is moving at roughly a quarter of the speed of light. But neutron stars have another secret. When two of them find each other, circling closer and closer over millions of years as they radiate gravitational waves, they eventually collide. And what happens in that collision is extraordinary. In 2017, telescopes around the world detected both gravitational waves and light from a neutron star merger for the first time. The collision lasted less than 2 seconds, but in that brief moment, it created more gold than exists in the entire Earth. The platinum in your jewelry, the gold in any ring or crown, was forged in the collision of two dead stars, billions of years ago, in a galaxy far from our own. We are not merely children of stars. We are children of neutron stars. The heaviest elements in your body, the iodine in your thyroid, the strontium in your bones, were created in these cataclysmic collisions and scattered across space to eventually become you. Neutron stars are the universe's recycling system. They take the remains of dead giants and turn them into the raw material of new worlds. New life, new stories. The next time you hold something made of gold, hold it for a moment and consider its history. It did not come from a mine. It did not come from the Earth. It came from a collision between two dead stars at the speed of light in a flash of light brighter than the sun. And somehow, it found its way to you. That journey is more than extreme.